So the lessons are recorded, guys. By the way, because some kids I know they can't make it on some of the days. So it's all recorded, guys. And so if you want to go back and listen in, you can listen in also as well, guys. I will share the email. I got the emails, guys. So I'll share the recordings, and so weekly you can go in and take a look at what we did. So let's kind of go back, guys, to atomic structure a little bit. And there's more to talk about, by the way. Okay. So atomic structure, guys, as we know, it's one of the things that we talked about towards the end of last week, guys, quantum mechanics. So we talked about, guys, and also the reading I gave you guys, I mean, I kind of went to like Dalton, to how into quantum numbers, guys, and stuff like that. So I'm not going to repeat too much of that. But one thing that we talked about is quantum numbers. Okay, so like what's something significant about the quantum numbers, guys, is the understanding. So it's all about the electrons and where the electrons are at and how the electrons are behaving and all that stuff. Thank you. So that's where, kind of, this was going, right? So one thing that we talked about, okay, is the dual nature of the particles, okay? Dual nature. So one of the things that we talked about, guys, I mean, is that how light can act as a particle of the wave. Okay, same thing, right? So they're understanding the electron can act as what? Dude, electron's a particle. Electron's a mass. Okay, electron's a mass of what? Mass of 9.11 times 10 to the negative 31 kilograms. Okay, that's the mass of electron. Okay, so not that you have to memorize, guys. By the way, you don't have to write it. It's fine. But they got mass. Okay, so this is actually electrons got a physical mass. Okay, they can move at a certain speed. But now, one thing that they mention in the quantum mechanics, okay? This is AP Chem, right? So with the AP Chem knowledge, guys, again, so again, like keep in mind, this AP level, guys. I mean, again, it depends on the student, guys. This goes into the MCAT level. They're about the same level, by the way. So which means, like you save your time now, learn it now, and so that you don't have to go crazy, guys, when you study for whatever this is what you have to do in the future, guys. Okay. So again, so what the understanding is, okay, electron is what? Dude, electron is a wave. Electron act as a wave. That's one of the underlying basics of the quantum mechanics. Okay, so it's not a particle with speed. It's what? It acts as a wave. That is one of the most important concepts of what? Quantum mechanics. Okay, so. So where these electrons are, so it's kind of, dude, like can you find electrons react? I mean, so can you find like the exact location and the speed of the wave, guys? You can't. That's exactly where they're going because I mean they're understanding. Oh, we don't know where electrons react. Okay, that's why they kind of mention what uncertainty principle. Okay. So uncertainty principle is the Heisenberg, right? You probably heard this guy's Heisenberg uncertainty principle. So what do they say? Oh yeah, dude, like they come out and flat out says what? We do not know the location and speed of electron. We don't know. Okay, that's what they're like. Okay, so that's what they're saying, right? Because why? Electron is a wave. Okay, and then so they kind of talk about what? Oh yeah, where there's a highest probability where the electrons can be found. Okay. Oh yeah, we think. Okay, this is where electrons can be found, right? What do we call that, guys? That's called the orbitals. Okay, it's called the orbitals. So within the orbital, okay, there's where the highest probability where electrons can be found. Okay, that's probably the core of the quantum mechanics. Okay, and what do they try to do, guys, here now? They try to what? Give them something we call quantum numbers, which is address for the electrons. So they're giving the address for the electrons, right? So for I think one of the best way to kind of understand this is this. Okay, so I'm not trying to make you guys freak out here, but if someone tells me the student's address, okay, so now you can do what, guys? If I know someone's address, what happens, guys? If they give me, I mean, not student, like someone gives me the address, right? Not to guys be a creep here. Dude, like people can Google map the address and see where that house is now, just to pick you up or whatever, okay? Pick someone up. So a lot of times, okay, so if you know someone's address, you're in that house, okay? But do you know exactly where the person is or the location of that person, guys? You don't. Okay, you could be in the basement or the first floor or the living room, bathroom. And do you know how fast the person walks? Like how fast the person is, guys, moving? I don't know. Like the person might be sitting, laying down, walking, running. Who the hell knows? Okay. So that's what this is. Okay. So they're providing the electrons with what? Quantum number. That's the address for the electron within the atom. Okay. So, but it's like the thing. Like they're 4 numbers. Okay. 4 numbers, right? So principal energy level. Okay. This is called the principal energy level. Sublevel. Yeah. No, at least you have to know symbols. Okay. Principal energy level notated as N. Okay. And now L is what, guys? Sublevel. Okay. Sublevel is what, guys? Like SPDF, right? SPDF or the sublevels. And this is what, guys? This is ML, which is the orbital number. Okay, there's a more technical name for these guys, by the way. Okay, there's like more technical name for these guys, which I don't think you have to know. MS is called a spin. So with these 4 numbers, which is what we consider as, so again, they're providing the quantum number, the address for each electron. Okay, each electron is provided guys here. Okay? So this electron has this address, and this electron has that address. Okay. So if you know the quantum number for the electron, okay, you can kind of try to find out where they're at, but you do not know the exact speed or location. Okay, that's what this entire thing is going. Okay, and now these are numbers. Okay, like for example, guys, this can be 2, like 0. Like this can be 0, like plus the number. That's an example of a quantum number. Okay, do you have to know this, guys? Absolutely not. You do not have to know quantum numbers, guys. You don't have to, which means AP level perspective, they will not put you on the spot and try to figure out quantum numbers, guys. Okay, we talked about it last week, guys. So there's no reason to like really know what this is right now, guys. But one thing to be sure, guys, there are some principles. I tell you guys, this topic, like with the electrons and all, is one of the hottest topic back in like early 1900s and 1950s. Okay, it's the hottest topic. Okay. So the scientists follow where the hot topic's at, okay? Like, if there's atomic stuff is going really booming, what happens? Scientists all go into what? This field, okay? Because what? That's where the money is, and a lot of help and money's there. Like they can, if they do something, they're gonna get Nobel Prize or stuff like this. So basically, guys, Heisenberg was one of them guys. Like Einstein, was one of them guys, and then Planck was one of them. So they're all going there, okay? And then there's a guy called Pauli's exclusion principle. Okay. So, it's very simple stuff, by the way. I don't know. So I was telling some of the folks actually, if you go back in time, guys, again, make sure you guys take these equations and propose them before these guys do, because it's not that hard. So this guy kind of mentioned what, guys? Okay, by the way, single atom. Okay, a single atom, just like how you guys, 2 of you guys will have our same address, right? Same thing. So in a single atom, an atom, 2 electrons will not have same quantum number. That's what this rule is, okay? Pauli's exclusion principle. That's what it is. Very simple stuff, right? So that's what this guy says. We still talk about it, right? So this number right here is what unique for a particular electron within the atom. Okay, that's one understanding of quantum mechanics, guys, by the way. Okay. So what do you guys have to know? Okay, in regards to this quantum mechanics, I tell you guys one thing. Okay, you guys have to understand. You guys have to know how to write the electron configuration. That's it. Okay, that's where we left off last week, guys. 1s2, 2s2, 2p6. That's where this is all going to. Okay, so the sublevels, the number of orbitals, and all that stuff. That is basically where this is going. Okay, and that's what you have to know. So one thing to note, guys, in terms of sorry, the electrical configuration, right? So I kind of rushed on this one, guys. I hope you guys really notice a little bit, guys, because I know some of you guys do this worked on this a little long, in a while, not in a while. So just so you know, guys. So first principal energy level, okay, which is N1, right? This represents, guys. Break it down, guys. N, which is a principal energy level, right? The first and second, third, fourth, like the fifth and sixth. Okay, there's 7. What's the 7? Right? This sublevel. Right? So if you want to break it down, guys, okay? Sublevel. So in terms of the sublevel, so which means they got one sublevel, which is what? S. Okay, the first principal level has S sublevel only. So you guys have the periodic table I give you guys. So it only has S sublevel only, guys. Okay. And one thing to note, guys, okay, the sublevels, you know, they have electrons in there, okay? I'm sorry, orbitals, right? Orbitals in there. So as we talked about that quantum perspective, N, L, ML, mass, right? That's sublevel. So this is like either SPDF, okay, that's sublevel. So keep in mind, guys, here, okay? So if you want to know, guys, keep in mind this is a quantum number, okay? You do not put S there, okay? There's a number associated with them. So for example, guys, like this S sublevel refers to as number 0, P is 1, D is 2, F is 3, okay? These are converting number for the sublevel SPDF. Is there a G? Is there like, you know, the other ones like H, I? Yes, there is. You'll never see them, okay? So if you guys go to college, if you guys go to a tough school, then yeah, you probably will see like G, H, I sublevels, by the way. But in your AP, even for Olympiads, guys, even if you go to Olympiad Chem, guys, you'll never see these guys, okay? It only stops at F only, okay? F is where, you know, it kind of stops for you guys. So keep in mind, guys, here, so one thing to be sure, guys, S sublevel, okay? It's got only what, guys? One orbital only. So again, orbital is what, guys? Where the electrons can be found, right? So this is where S sublevel got only one orbital, okay? P, okay? It's got what? P's got 3 orbitals, okay? So it goes by 1, 3, 5, 7, okay? D has 5, F has 7. Okay, these are number of orbitals. Okay, it's kind of straightforward, guys. You guys should definitely know this. Okay, S has 1 orbital. Okay, P's got 3 orbitals. D's got 5, and F has got 7. Okay, there's a number of orbitals that you can have. So if somehow you like, okay, so hope not, but let's say you forgot. Okay, let's say you forgot. Okay, so I don't know how many orbitals that they have. Okay, in case, okay, you know, just I don't know, you guys are really tired or whatever, and you don't forget this. One way to tell, okay, based on how many orbitals you got, is basically this, okay. So if you have an S, which is a 0 as the sublevel number, okay, you got 1 orbital. Okay, orbital number, guys. Orbital, and so the shape of the orbital, guys, can be given as a little box, guys. Like a box is an orbital, okay. And P got 3 orbitals, right? So one thing to note, guys, okay? The ones in the middle, okay? The number of, like, this is what, guys? Like the next, like the in some of the quantum number, guys, this is orbital number. This is the number 0 as an orbital number, okay? This is, here is +1, okay? And here is +2, and here is -1, okay? And here is -2, okay? So what I'm saying is, guys, okay? If the sublevel number, like P, is 1, right? They got what, guys? They got the orbital from what? -1 to +1. -1, 0, +1. You understand, guys, here? Okay? Look at D. D's sublevel number is 2, right? Which means what? They go from -2 to +2. Okay? -2, -1, 0, +1, which means what? They got what? 5 orbitals. Okay? That's one of the ways to tell how many orbitals they have. Okay? Keep that in mind, guys. So these numbers, okay, means something. Okay, when the scientists came to the number, guys, it is supposed to mean something. Okay, so now these numbers are what they call as what? Orbital number. Okay, this is the number 0. This is what? +1, +2, -1, -2. That's what they consider as orbital number. Okay, within the sublevel. You understand, guys? So S, their orbital number should be always 0. You understand what I'm saying? Okay, and P is what, guys? This guy is -1. 0, +1, okay? This is what, -2, -1, 0, +1, +2, okay? That's the orbital number, you know, for sublevel perspective, okay? F is what, guys? Like -3 to +3, okay? And I'll keep in mind, guys, here, each orbital, okay? So orbital is where electrons can be found, right? So each orbital can have what, guys? 2 electrons. Electron is drawn as an arrows, okay? Each orbital can have what? 2 electrons. Keep that in mind, guys. So guys, if you look at this, okay? So the first principal energy level, okay, has S sublevel only. One orbital, that's it. Okay, number of orbitals, guys, okay? Number of orbitals is what, guys? MS? I'm sorry, MS, I mean ML, I'm sorry, is what? You got one orbital only, because S sublevels has only one orbital only, guys. So which means what, guys? They have what? Number of electron perspectives, what? They got only 2 electrons. They can only have 2 electrons in the first principal interval. Okay? So think about it, guys, okay? This is the nucleus, okay? Plus charge here. This is the first N1, okay? So I have to draw it as a circle, okay? So just from this perspective, okay? First principal interval N1 has what? It's got only S sublevel, which is one orbital, which can have 2 electrons only. Which means what, guys? If I put 2 electrons on these guys, what happens, guys? I run out of space, okay? If I have to put more, what happens, guys? I gotta go to the next shell. N2. You understand, guys? You understand, guys? So if an atom has 2 electrons, or 1 electron, you can put them in what? The first principal interval. But if you got more, what happens, guys? You gotta go to the next one. Okay? So you gotta fill in from the first one, and second one, and third, and fourth, and fifth. It kind of goes like that, okay? So that's the reason why, if you guys go to the periodic table I gave you guys, what happens, guys? If this is a periodic table, right? This is what? Like, the first one is what we'll call what? The first principal interval, right? They're only what? They only have hydrogen and helium. That's all they got. Yeah, so why are they only 2? Is what? As we discussed, if you put 2 electrons, what happens, guys? The first shell runs out of space. That's why they have to go to the next one. Okay, the second shell, right? That's why they only have like 2 elements only. Okay? And now, guys, so second principal interval. Okay? They got what, guys? S and P. S sublevel and P sublevel. Okay? So now, so S sublevels got 1 orbital, P's got 3, which is what overall? It's got what, guys? It's got 4 orbitals overall. Okay? And as we discussed, 2 electrons per orbital, you can have up to what? You can have up to 8 electrons overall. So if you put 8 electrons in the second shell, what happens, guys? They're filled up, okay? So which means what? Okay, so you look at it here, I can put up to 8 electrons. Okay, you probably hear 8 a lot, guys. 1, 2, 3, 4, 5, 6, 7, 8. And what happens, guys? Filled up, okay? That's the reason why what happens, guys. You got 2 here, you got 6 here, okay? And what happens, guys? If you go above that, you gotta go to the 3rd level, okay? So do you understand, guys, here? So you need to understand, guys, here. So let's talk about carbon, because carbon is brought up a lot. Anything like that, the second principal interval, that's where a lot of questions are based on. So second principal interval is where, so if you look at the periodic table, guys, second like level, right? So this is the S block of the periodic table, this is the P block, right? So this is the S side, this is the P side, right? I mean, dude, like, this is AP class, you probably have some background, right? So, as we know, guys, okay? So, P side has what? Like, this one is, the second level, guys, like lithium and beryllium here, and then we have a boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, that's the second level. Okay. So second principal level. So as we know, guys, how many can you have, guys? 1, 2, 3, 4, 5, 6, 7, 8. That's it. Okay. If you fill 8, what happens, guys? It runs out of space. You have to go to what? 3rd level. Okay. And now, like, dude, like I tell you guys, like one thing to understand, guys, let's kind of talk about it, okay? Let's talk about the electron configuration, and it's something you have to know. So it's kind of not too bad, guys, here. So for example, guys, let's talk about carbon. So the question will be asking, guys, a very basic question that we discussed last week as well, right? The question will be asking, write the electron configuration for carbon. Okay, so what would that be, guys? So you gotta write like 1s, 2s, and 2p, right? So keep in mind, guys, I mean, so they have electrons here, here. So carbon's got what, guys? 6 electrons overall. Okay, 6 electrons overall, right? So the 1s, the first principal interval S sublevel is what? It's filled up with how many electrons, guys? They got 2 electrons overall, right? 2s, 2, right? This is something you guys kind of know, right? Second, 2 electrons goes in here, and what? And how many electrons in 2p? This is 2p block. Well, how many do you have? 1 and 2, right? So 2p2. So this becomes what, guys? This becomes what we consider as electron configuration for what? Carbon. Very simple, right? But what about nitrogen, guys? Nitrogen's what? Yeah, it's very simple, right? This becomes what? 3. Okay, because what? They got 7 electrons. Do you see that, guys? But now, one of the things you have to understand, guys, is what? Something we call Hund's rule. So Hund's rule kind of mentions about how you fill in the electrons in the orbitals, okay? So, so guys, one thing to understand about the Hund's rule, guys, is this, okay? So it doesn't really apply for these guys because they got only one orbital only. P, okay? So if you consider orbital as a box, okay, P block has what? 3 boxes, okay? And it's got what? 3 electrons. So how do you distribute the electron in the orbital? That's a question to ask yourself, right? What do you think, guys? So, which means, okay, do you do this? Like, do you actually make them line up together, put 2 electrons in one orbital, and then leave one blank, guys? You do not, because what? You have to what? Distribute the electron first in each of the orbital first, okay? That is what we call Hund's rule, okay? Hund's rule is what, guys? When you're filling in the electrons, first one here, 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 and then if you run out of space, what happens then? You couple them, okay? You do this. The way you fill the electrons in the orbital is what we call the Hund's rule, okay? They definitely test this on the AP, guys. It sounds very simple, okay? But you definitely have to know it, guys. And they will ask you guys, okay? Like, why? Why is there something we call Hund's rule, okay? So the reason is, reason why, you know, like dude, like, I'm telling you guys, like, this is where, guys, again, as I mentioned, guys, like, this was very booming, okay? Like, oh yeah, Adam, you put something, you contribute something, your name gets onto the principles and stuff like that. So like, dude, like this guy, we still talk about it because why? Yeah, that's what he did, okay? So, if you think about it, right? So, why does it follow this pattern? So again, these are electrons, right? Electrons are negatively charged. This is very important, guys, by the way, okay? They are negatively charged, okay? They do not want to be close to each other, okay? They repel each other. You understand what I'm saying? So these orbitals, yeah, what's an orbital again, guys? Where electrons can be found, okay? So now, electrons repel, okay? There's a little room for the electrons, right? So they are trying to be as far away from each other as possible, okay? They want to be as far, okay? Like, dude, like, get the hell away from each other, okay? So to do that, I mean, why would they share the same room when their one room is available? Okay, they don't want to do that, okay? So typically, for example, think about it, guys, okay? You guys have like 2 siblings here, okay? You guys have 3 rooms for you guys. Would you share? Like, dude, you got two, you know, brother and sister, guys. You got 3 rooms for you guys. Would you share one? Absolutely not, okay? Like, why? Because you guys can't have room for each other, okay? Same thing, right? So, because they don't like each other, electrons repel. So, in terms of understanding the shape of the orbitals, guys, okay? So orbitals are not boxes, by the way. Like, dude, orbitals are not boxes, okay? So, the actual p orbital shape. So, I think for the AP, you have to know the shape of the s orbitals, s sublevel orbitals, and p orbitals. D, you don't have to go that far. So, if you look at these are, guys, we call the px, py, pz orbitals, okay? So, x, y, z's, because why? They're x-axis, y-axis, z-axis. So, this is the x-axis, y-axis, and z-axis. Okay, I'm sorry, can't draw. So, so this is x, y, z, and the orbitals look like little lobes. Okay, that's what it looks like, by the way. Okay, so they're 90 degrees to each other. Okay, that's what actually looks like. So, yeah, one of this guy is what? It's one lobe, like one of this guy. Okay, and they can move around. Like, dude, they can be like, yeah, dude, as we talked about. Yeah, these are waves, right? Like, dude, these are waves, right? Like, dude, like you see that guy's like a wave, okay? Like standing wave like this. They're waves. They're in there, okay? Where? I don't know. Okay, they don't know. Okay, that's the Heisenberg uncertainty, right? But think about it, guys. Okay, electron here. Do you want to put something here, guys, where they can meet, get close? No, they don't. They want to be what? Put the electron, second one into what? The next lobe, okay, and the y-axis. They can be as far away, 90 degrees, at least 90 degrees from each other. And the next one is what, guys? Put it here. So each are what, guys? At the axis from 90 degrees at most from each other, okay? At like closest to each other. That's the reason why, okay, Hund's rule applies. Again, going back to the statement here, why do they follow the Hund's rule, guys? Because why? Electron repulsion. That's why we have Hund's rules. Very, very important, guys. You know, it sounds like very simple stuff, right? Like, you know, like, okay, 1 on 1, you know, and then okay, so you know, but you understand the underlying understanding, like why? Okay, so think about it, guys. The farthest away is what, guys? Like yeah, 90 degrees here. Okay, and if there's one more there, 9 degrees. At least they're what? Like yeah, at the angle of 90. That's 100. So make sure to understand, guys, what it means, how do you fill electrons in, okay? So the 100 doesn't really, like, the electron configuration doesn't really follow the 100, guys. I mean, it is what it is. I mean, number of electrons, guys. But when they start to talk about, okay, like ground state, for example, then you have to understand, guys, okay? Ground state is what, guys? Like, you're filling the electrons as, like, the numbered ways, like, you know, like first one, second one, third one, following the 100 rule and stuff like that, okay? All right, so again, the S and P guys, they have electrons, guys. And third level guys, they have an SP and D. And fourth level down, they have what? SP, D, and F. That's what you know. And now SPD guys, as we talked about, S has 1, P has 3, D has 5, okay? Overall, this is what, guys? Like that's overall what? 9 orbitals, which is 18 electrons overall, okay? So you guys done the reading, guys. You guys should definitely know this one, guys. Where this is a third level, the 3s here. Okay, this is a 3p in the periodic table, guys, and then 4s, and then 3d. Okay, 3d comes after 4s. And make sure to say, guys, it lags one back. Keep that in mind, guys. Okay. So keep in mind, guys. Okay, once you like here, like copper, whatever here. Okay, copper, like iron, like you know. Chromium and stuff like that, guys, okay? D level lags after 4s, okay? So it's not 3s and 3p and then right away 3d, okay? It fills up 4s first, okay? Keep that in mind. So keep in mind, guys, just so you know, have you ever heard the term, guys, octet? You've probably heard the term octets, right? Oct means what, guys? Oct means what, guys? Oct means 8, okay? Oct means 8, okay? It's not October. October means like 10, right? But that's oct means 8. So what is octet rule, guys, by the way? Octet rule is so you probably heard this term, guys, quite a few times, octet rules. So octet rule is what, guys? Oh yeah, you're trying to like valence electrons. Okay? You try to complete an octet, which is 8 electrons on the outermost shell, and what? They're very stable. Okay? Where does this come from? So what do we consider as an octet, or the valence electron, something to understand? So now, keep in mind the answer first, okay? Electrons in the outermost S block and P blocks, right? The S and P blocks. They are the ones you consider as an octet electrons, okay? Or, I'm sorry, the valence electrons, okay? So now, the outermost electrons in the, you know, like whatever this is and whatever that is, number of electrons here, okay? On the outermost S and P, they're considered they're what? Valence electrons. So which means what? Keep in mind, guys, for your level of chemistry, right? Electrons in the D block and P, right? They're never considered valence. Never. Okay? Which means what? 3D, 4D, 5D, like 4F, like 5F, they're never considered valence electrons. Okay? And valence electrons, what, guys? Only S and P. Okay? So for example, listen carefully, okay? For example, if you guys have a periodic table. So if you guys look at copper, so I forgot which number that is. If you guys have a periodic table, guys, I gave you one, right? Copper, guys, this is a reading, right? I didn't give you the reading, right? You don't, if you're cold, like sit up there because like the wind blows, right? So if you guys take a look at I need a periodic table. I mean, you guys have a periodic table, right? So copper, wherever the copper is, guys. So what happens, guys? This is what? Argon, in terms of configuration, argon and what? 4s2. 4s2, 3d10, guys. Oh, zinc, I'm sorry. I'm going to give you zinc as an example, okay? Okay, that's the configuration, right? Right, that's the electrical configuration for zinc, okay? So zinc is like right there, right here, or something like that. Yeah, so, yeah, question is, how many valence electrons do they have? Is what? Like, do we consider this electron, 10 electrons as valence, guys? We do not. Because why? Outermost is a 4th level, not 3rd level. Do you understand, guys? Okay, which means what? the number of valence electrons what, guys? On the outermost S and P, which is what? Yeah, 2 electrons only. You understand, guys? Here. So d block electrons are never considered the valence. Keep that in mind, okay? So which means what, guys? Okay, so outermost electrons what, guys? Again, 2 on the S, 6 at the P, which means what? They're up to what? 8 electrons overall. Okay, you'll never consider d block and f block as a valence electron, which means what? That's why we call this what? Octet rule. Because what? Only the outermost S and P considered outermost. D will never be outermost. Okay. Any questions, guys? Let me know. So that's one of the things that we talked about, right? If zinc, zinc comes what, guys? One of the things you have to memorize with AP Chem is what? Zinc becomes 2 plus charge, right? Zinc loses 2 electrons. Where does it come from, guys? Is it 4s or 3d? What do you think, guys? Always the outermost. What, this guy? So when they lose electrons, it's never 3d. It's what? The 4s. They lose it. Okay. Because why? Only the outermost electron will be what? Reacting. I mean, they react first, okay? Like not only them, just you know. And I tell you guys one thing, okay? F block electrons are never asked on the AP. They never ask F blocks. So they don't go into like this guy's F blocks. So you don't have to know that. So they really stop at guys like the D block questions, okay? They don't go into F questions, okay? So your teacher might, I highly doubt, but you know, F blocks are something that we really don't have to really go too far in terms of understanding, okay? So keep that in mind, guys, where this is going. And again, I will not do exercise again to do the electrical configuration, guys. I mean, that's something that I'm sure you guys have an understanding of it, guys, at the moment. Any questions, guys? Let me know. Questions there so far? Let me know. All right, so I would like to jump in, guys, right now to the, so this is at an AP level, guys, okay? So I would like to discuss the next level, which is a periodicity now, okay? Which is the next sector of the reading. So, hope, I don't know, we can finish a little bit and I can give you some questions and we'll discuss. Sorry. Okay, so guys, periodicity, which means like, oh, you guys have a periodic table, and then it tells you, it kind of, you know, discuss about like some patterns on the periodic table, okay? So I should do this, and then keep in mind, guys, there is something that you guys probably never heard, guys, something called binding energy. I definitely have to talk about it today, guys, because binding energy is something you guys have to know. You know, probably I'll discuss after we discuss all the periodicity stuff, okay? Yeah, because this will be definitely on the AP, and we'll be on the homework. All right, so let's see. All right, so I'm sorry, guys. I gotta get the air going, guys. Like to circulate the air. You know, the delta variance. You know, so get this going. All right, dude, I tell you guys, like I work from home and I barely go out. Just so you know, so I'll be the last person to get it. So, you know, so the COVID and all, guys. Like I barely go out anywhere. I go out to pick up food maybe and come back home. I mean, so. If anyone's gonna get it, guys, I'll be the last one. So, unless like you guys like, you know, cough and whatever without a mask on. All right, so all right, let's talk about, guys, periodicity. Periodicity. Okay, so this chapter, guys, okay, we'll be discussing a few terms and understand what they are. So first thing first, guys, negativity, okay, and then also, guys, energy of ionization and patterns, okay, and also, guys, it's energy of ionization, okay, I'm not gonna write it, and also, guys, electron affinity, and also, guys, negativity, and also, guys, atomic radius, atomic radii, also ionic radius. So pretty much these are it, guys. Periodicity, but we'll talk about, guys, each of the unique, you know, like groups and, you know, what you guys have to know for each of the groups, okay? This topic. So let's talk about the easy ones first, get it out of the way, okay? Let's talk about electronegativity. So this one, I tell you guys, electronegativity is something that they talk about a lot, okay? In bonding, actually, in bonding. So, so electronegativity is a number, okay, that runs from 0 to 4. There is no unit for this number, okay? It's some kind of a, you know, it has to do with, guys, it's some kind of system they have. I mean, it's in the textbook, guys, but I don't think I have to go that far. The number system, they go from 0 to 4, okay, relative to the elements that we have. And there's nothing with 0 value. I think the lowest one is cesium with 0.7 or something. And F is the fluorine has a 4.0. So you gotta know the definitions like really well. I mean, have people understand what the numbers represent, but not the direct definition of what it represents, okay? What this term is. So electronegativity, okay? So I'm not gonna write it, guys, okay? So this value of the element, okay, represents how strong an element attracts bonded electrons. That's the terminology, okay? So when element X and Y, they bond, okay? So this is not, that's the term, like, dude, like, I tell you, bonding, right? Because of the term bonding, that's the reason why, like, in bonding chapter, this is where this, like, term electronegativity is discussed a lot, okay? So keep in mind, guys, okay, so the definition first, okay? How strong the element is attracting the bonded electrons, okay? So if the electronegativity is 4.0 versus like 2.0, what happens, guys? Yeah, the electrons are more attracted to 4.0, okay? And so it's a bonded electrons, okay? Not an entire thing, just the electron that are bonded. That's a definition of what? Electronegativity. So, as you know, guys, so keep in mind, one thing to understand is, so, okay, what bonds? So which element will bond and which element will not? So what's the purpose of bonding? So, dude, like, what is the main purpose of bonding for the elements, for the atoms? What? They want to have what? Octets. You know what I'm saying, guys? Dude, they want to have an octet, okay? They want to have the outermost electron as what? 8 electrons overall. Okay, that's what they want. But now imagine, guys, like think about it, guys. If you already have octets, would you bond? What do you think? You don't, okay? So now, if you look at your periodic table, guys, okay? If you look at the periodic table, guys, the octets, which have 8 electrons overall, guys, as a valence electron, guys, the noble gases. Noble gases, what, guys? They already have octet, okay? They already have what, guys? 2 electrons in the S, and what? 6 electrons in the P's. Okay, they already have 8 electrons overall, which means what? They will never bond. They will not bond, okay? So keep in mind, guys, your electronegativity applies for the elements that bonds, okay? Which means what? Noble gases are excluded from this list, okay? From this pattern and such, right? So if you look at it, guys, so the highest one is what, guys? The highest one, fluorine has the highest electronegativity value of 4.0, okay? And here, which is what, like, there's a cesium here, guys, a francium FR, and they're the ones that are what, guys, the lowest value. Okay, they're like 0.7 or something, you know, and this guy's what, 4.0. And now these are excluded, okay? And number 2 guy is what? Oxygen. Oxygen is number 2. Okay? And next one is what, guys? Chlorine. You have to at least know number 1, number 2, number 3, okay? Fluorine number 1, oxygen number 2, chlorine number 3, okay? You gotta know like first 3 at least, okay? The value perspective. So keep that in mind, guys, what it represents, okay? So it only applies for the ones that bonds, okay? So noble gases do not, it's not available. It's like, it's not a 0, it's not a 4, it's what? Not applicable, okay? So a lot more to discuss with this guy, okay? Electronegativity value, guys. And so like bonding wise, okay? Like typical rule is what? If the difference of the electronegativity is a certain value, like this, what happens, guys? They will create ionic bond, okay? But if it's under a certain value, it's what? Covalent bond, okay? That's something that they mentioned, okay? In the bonding chapter. So you should definitely not forget this. You should not forget anything, by the way. But this is something that we discuss a lot in the bonding chapter, by the way, okay? Okay, let's talk about, guys, energy of ionization. Okay, but before that, guys, let's talk about the atomic radius first. This one is harder than you think. Okay, we talked about this guy. Let's talk about the atomic radius. I tell you, you gotta understand, okay, how to write a response on the AP. Okay, let's take a look. So in terms of atomic radius, so sorry. So the understanding atomic radius, guys, is so you have to understand, guys, like how do you measure this thing? Okay. So what is atomic radius, guys, and what do you have to look at? So as per our discussion, okay, if this is the atom, and this is the nucleus is a very small portion, right? Very small. So atomic radius is what, guys? So I'm not going to talk about, guys, like ionic radius or anything like that, guys, or covalent radius. I'm not going to go that far. I'm just going to strictly just stick to, guys, so what I think is an atomic radius. So this, like again, like circle, right? Circle has a radius, okay? But you got to understand, guys, what the hell is out here? Put your phone away, please, guys. What the hell is out there, guys? So, like, you got to understand, okay, it's what? The valence electron. So the question becomes what? How far the valence electron is from the nucleus? Okay, that is basically what? Like, indication of the atomic radius. Okay, so atomic radius is really large. What do you know, guys? Yeah, dude, like the valence electron is really far away. Okay, that's the understanding, right? So how far the valence electron is from the nucleus will decide the size of the atom. Okay. The size of the atom depends on what? Like, dude, like, okay, like radius of the atom, okay? So, like, think about it, guys, okay? How do you have a small radius and how do you have a big radius of the atom? So, which is basically what, guys? If they have greater number of what? Like shells of electrons. The first shell, second shell, third shell, fourth shells, which means what? Which means that there's a less number of N, which is what? Principal energy level. So, dude, like N is what? The principal energy level, the first shell, second shell, N1, N2, N3, N4. So, smaller the N number is, principal energy level number, which means what? Yeah, there should be what? It should be a smaller atom. Okay, so if you look at the periodic table, right? So, if you look at the periodic table, guys, a very simple understanding is what, guys? So, this is the first shell, second principal energy level, third, fourth, fifth. Okay, which means what? I mean, like, understanding is what, guys? If you're here, the atom is here, atom is down there. This is what? Second principal energy level for the outermost. This is what? The fifth one. Which means what? This should be smaller because what? They have less shells of electrons. Okay, that's obvious, right? So, which means what? As you go down the periodic table, if you're given, what happens, guys? They get bigger. You understand, guys? So, I mean, like, dude, like, how obvious, man? Like, if you're bigger, more principal energy level, what happens, guys? They're what? Bigger atom. No question there, right? So typically the rule is what, guys? If you go down from the periodic table top to bottom, they get bigger. No question there, right? That's like plain simple, nothing fancy, okay? But the problem always is what? Going down the table. Okay, that's always the problem for the students, every time, okay? And you have to exactly know why. Okay, like, okay, so why, like, it behaves in a certain way. I mean, you guys should definitely know the answer, guys, for this one. If you go from, for example, guys, we talked about, guys, this is this is basically, guys, lithium. This is beryllium. It's a boron, like carbon and neon and blah blah blah. It goes down, guys. What will happen to the size of the atom? So, like, I mean, dude, think about it, guys, right? If you go down from the left to right of the periodic table, dude, like, think about it. You got more protons, you got more neutrons, you got more electrons, and absolutely no question the size will get bigger. Okay, like in people's head, right? Is it, guys? No, the size actually gets what? Smaller. Size of the atom is smaller from left to right. There's no question there. So this is something that you should kind of know, guys, from the regular chem class, guys. From left to right of the periodic table, from the same principal energy level, they get smaller. So that's a big thing to understand, okay? And like, okay, so atomic radius gets what? Smaller from left to right of the periodic table, okay? As the atomic number goes up on the same principal energy level, what happens, guys? The size gets what? Smaller. And you have to know why. You actually have to know, guys, why does it get smaller? That is something you have to know. Okay, very, very important, guys. The reason is FRQ question, guys, on the AP Chem, guys. Okay, they ask this question. They ask you to explain. Okay, explain why it gets smaller. Okay, because like, dude, it doesn't make sense. Like, dude, like, okay, so how is that possible, man? And your answer should always have this. Okay, effective nuclear charge. Every time. Effective nuclear charge is the answer. Okay? So let me explain to you what that is. So effective nuclear charge is noted as what, guys? ZF. Okay? And ZF. So Z symbol in chemistry, at least for this chapter, is what, guys? Z represents nuclear charge, which means number of protons. Okay, this Z means number of protons. F, like effective, okay? So effective nuclear charge. That's what it means, okay? So there's a way you can calculate this, but I don't think calculation is really needed for us. Okay, but let's talk about like what's happening. So equation first, let's mean equation first, okay? ZF equation is equal to Z, which is number of protons. Okay, how many protons you got? Minus what, guys? Minus number of non-valence electrons. Okay, that's the equation, guys, for the ZF, which is effective nuclear charge. So for example, guys, okay, let's talk about carbon. Let's talk about carbon. So carbon have what, guys? They got 6 protons, right? 6 protons, right? In terms of a configuration, guys, 1s2, 2s2, 2p2, right? That's basically what it is, right? That's the understanding of what, guys? So configuration for carbon. So now, yeah, how many electrons is what? Is a non-valence electron? 2. You know what I'm saying, guys? So this is what? Non-valence. Second principal energy level is what? Valence. Okay? Non-valence 2, that's 4 is a valence electron. Minus 2, which is what? Effective nuclear charge is what? 4. 4 is what, guys? Effective nuclear charge of carbon. So what the hell does it mean, guys? What does this represent? How much of a nuclear charge actually gets to the valence electron? So meaning, guys, think about it, guys. Okay, this is a proton. This is the first shell. That's the second shell. Okay. You gotta understand, guys, something called, very carefully, guys, shielding effect. Shielding. What shielding is this. Okay. What shielding is what? Nuclear charge electrons is what? Attracted to the nucleus, right? So we know. But there's what? This is the first shell, this is the second shell. What's happening, guys? Yeah, dude, like, okay, the positive charge attracts the second shell electrons. What happens, guys? But shielded by the nucleus. You understand, guys? Which means what? This first shell electron, what? Shields the electron from what? The second electron. So it doesn't get that strong a pull because of what? Non-valence inner electrons. Okay? So that's what ZF represents, which is what? How much of the force do they get from the nucleus, excluding the shielding? Okay? I mean, including shielding, which is what? How much of the shielding effect takes in place? Okay, and how much of attraction are they getting? That's what ZF is. Okay? Stronger the ZF, or higher the number is, stronger the attraction is. You understand, guys? Okay? So again, keep in mind, guys, okay? Strong the attraction for the valence electron, there be what? Pulled in stronger, pulled in more to the nucleus. Okay, so if the ZF is higher, what happens, guys? They get more closer. Okay? And what? In turn, the radius of the atom will be smaller. Okay, because what? They have a stronger attraction. So okay, let's talk about, guys, okay? In the same period, let's talk about what, guys? Let's talk about this other guy, which is let's talk about fluorine. Okay, fluorine, right? Fluorine is what, guys? Fluorine's got 9 protons, right? So this becomes 5. So we got 2 electrons in the inner shell, and we got what, guys? 7 valence electrons. Okay? So for fluorine, if you look at it, what happens, guys? There are, this becomes 9 minus 2. So this doesn't change, okay? I didn't change the number of what, guys? Inner electrons. Okay? They're the same electron shell, okay? Like, look at 2 and 7, right? Which is what? This becomes 7. Okay? When you go down the period, fluorine is what? Is on the left, okay? of carbon. So keep in mind, guys, in second level, guys, carbon is here, fluorine is here. Okay, I went down the periodic table, okay? What happens, guys? This went up. 7, right? Which means what? I mean, like, dude, like, ZF increases. What does it mean, guys? The valence electron is what? Attracted stronger to a nucleus. ZF again is what, guys? How strongly the valence electron is attracted to the nucleus. Because of the ZF going up from the left to right, what happens, guys? The valence electron is pulled in strongly, which means what? The radius of the atom decreases. There is no hiccup on this one, guys, you know, which means what? It progressively goes down, okay? Incrementally goes down as you go down from what? Left to right of the periodic table. There's no hiccup. There's no like, oh, it goes up and down, up and down. No, it goes down progressively, okay, incrementally from the left to the periodic table. You have to know this, guys, okay? Do not get mixed up, guys, here, okay? And why? You have to mention effective nuclear charge on the AP Chem chapter, okay? AP Chem exam itself, guys, okay? Who knows what the hell who knows how your teacher can teach this? I don't know, okay? This is what you have to mention, guys, in the AP exam. Any questions on this one? Let me know, guys. Questions, concerns, let me know. So, if you think about it, right? If you look at the periodic table, then what will be the smallest atom? Like, think about it, guys. Okay, so this is, if you look at the periodic table, guys, where would you have the smallest atom, guys? So it's like what? It's helium, this guy, okay? So helium is the smallest atom of all, guys. Okay, that's the smallest atom that there is. Okay, there's no question there. Okay, because as you know, if you go down, it gets smaller. If you go up, it gets smaller. So that's what right there. Helium is the smallest atom. Okay. Any questions, let me know, guys. So shielding, I tell you guys, shielding and like, I mean, there's a big component here that I'm not discussing. Okay. You know, like penetration and all, guys. So that's something that we don't have to discuss for this for AP Chem, guys. So there's a greater discussion on this one. Okay? If you guys go to higher chemistry, then there's more to discuss on this part. But for us, like this is it. Yeah. So like, so we don't have to go too far in terms of shielding and such, guys. So that's for when you guys go to college or Olympia chemistry. That's when they start talking about these guys. Okay? Like more than this. So this is fairly important thing to understand, guys, you know. Okay, any questions, let me know. All right, let's go to the next part, which is the energy of ionization. This is where a lot of questions also on. And let's talk about the definition first, guys. Okay. Okay. So, energy of ionization. You have to know the definition, okay, and also what? The periodic trend for this as well, okay? So the definition is what, guys? I mean, it's in the reading, guys, by the way. The definition is amount of energy needed to remove a valence electron of an element in a gaseous state, okay? So you have element X in a gaseous state, okay? So you're trying to remove electron in a gaseous state, okay? So your teacher might not bring up the gas there, but that's something that College Board wants you to know, okay? It must be a gaseous state, okay? Yeah, dude, think about it, guys, okay? You are trying to get the electron out, okay, from the atom. Electron is attracted to the nucleus, okay? Which means, like, dude, you're trying to get this guy out, which means energy must be put in for this. Work must be done, energy put in, okay? So energy needed to remove the electron from the atom, okay? So which means, so now this turns into what, guys? Positive charge ion, okay, and what? Electron removed. That is the equation for what, guys? Ionization process they're referring to in terms of energy ionization, okay? And the first electron removed is what, guys? What we call the first energy of ionization for an element, okay? And listen very carefully, okay? For AP Chem, you have to know slightly more from this one, okay? Than the regular Chem that you guys did. So when you look at this, guys, so they're gonna ask for the periodic strength, okay? It's like, oh yeah, which one has a greater value, smaller value, which one is easier to remove electrons? So when they say, guys, again, easier, okay, to remove electron. When they say easier, which means what, guys? Easier means low energy ionization, okay? It's easier means what? Yeah, it doesn't take that much energy to remove them. That's what we call what? Easier, okay? So which means, oh yeah, it's easy to remove the electron from the atom, which means what? Has a low energy ionization. That's what it means. So it's harder. So it's hard to remove electron from the atom, which is what, guys? E is what? High. It's more difficult to remove them, which means what? This is a very big number, okay? It takes a lot of energy to remove them. So dude, think about it, guys. When would it be very difficult to remove electron from the atom, the valence electron? When what? So okay, so this is a nucleus. This is a valence electron, right? When do you think this guy is very difficult to get rid of? When? When what? When is what? This guy. If you attract, this guy attracts the nucleus, right? When this attraction is very weak, okay, it doesn't have a strong attraction, then what? It's very easy to pull it out, okay? So either one or the other, right? If the electron is very far away from the nucleus, okay, it's like, dude, it's really far away, radius, atomic radius. So in terms of atomic radius, it's very far away. Okay, then what happens, guys? It's very, easy to pull this guy out, okay? Like, which means what? Easy means what again? Has a low energy ionization, okay? And also, guys, okay, so if the electron is very close, okay, to the nucleus, and what? Oh, it's very close, which means what? It has a very strong attraction to the nucleus, which means what? This is very difficult to remove, very high energy ionization, okay? So what I'm saying is, it's what? It's got a lot to do with what? Atomic radius, okay? So if you look at this, guys, so let's talk about, guys, the periodic trend, okay, in terms of the energy of ionization here, okay? So, I mean, what do you expect, guys? The smallest atom, which is what? Helium, should have the highest energy of ionization, right? Like, there's no question there. Like, dude, like, helium is the highest one, very hard to remove. Electron is very close to the atom. And also what, guys? Fr, francium and cesium, they should have what, guys? Very low, okay? About the lowest energy of ionization. There's no question there, guys, we know. So, which means if you look at the periodic table, the trend, the basic trend is what, guys? This helium is the highest one, okay, in terms of removing electron. This is what? This is the lowest one. So, like, dude, if you guys look at the highest and lowest, you get the picture of the trend, okay, so you know, that's the lowest energy of ionization, which is very easy to remove, highest, okay, so you get the understanding of the normal trend, okay, which means what? If you go from the left to right, what happens, guys? The energy of ionization overall increases, okay? If you go up, it goes up also as well, right? Like the trend, as long as you know the highest and lowest, right? And let me tell you something, okay? What year is he now? I think one of the students that I used to teach, guys, I taught him for like 4 years, okay? He went to, like, I still remember this guy. Because I taught him like from his freshman year, I think. He's a very smart guy. And then, so I was teaching him this, okay? And then he went to, so I mean, he's a very smart guy, very smart student, guys. And like, I taught him exactly what we talk about right now, okay? So it's like how we talked about, guys, and you know, I don't know what chemistry it was actually, I'm not sure. But was it AP Chem or just regular Chem? I'm not sure. But I think he's from the Bergen Academy in New Jersey. And one of the questions he asked me was, which I thought was a really valid question, by the way. But one of the questions was asking these guys, FR. So basically, what his question was, which I thought, it was like, okay, he went to Brown, by the way. He's a very respectable student, by the way. He's a junior now, I think. So he mentioned about this, FR. So I mean, even like smart kid like that ask questions. So feel free to ask questions, by the way. So FR, his question was, this one has a lot more protons. Okay, this what 80 proton or something? If I'm not mistaken, guys, compared to helium. Helium got what? 2 protons. This one's got 80. Okay, so I mean, he was kind of questioning because if you think about it, right? This is a nucleus, okay, positive charge, and that's the electron. And in chemistry, right? Every attraction is based on what? Between plus charge and minus charge. Every attraction you can, guys, between plus and minus charges, okay? And now between plus and minus, what do they have, guys? Coulombic attraction. Force of attraction, coulombic, which is force is equal to, guys, K times Q1 times Q2 divided by R squared. That's the equation, guys. So coulombic attraction. Okay, Q represents the charges, R represents what, guys? The distance between them. Okay? So what the question it was asking is, FR has what? 40 times number of protons. Okay, you see that, guys? 40 times. So which means, guys, okay, so if you look at it, yeah, dude, like, okay, so I understand, he said, I understand, you know, the electron for the FR is further away. Okay, but like he's questioning, dude, like they got 40 times number of protons. Okay, so shouldn't that mean something that where, you know, the attraction for the electron is relatively strong? That's a valid question. You understand? Based on what? The Coulombic attractions. Why is so yeah, 40 times I get it, but why is not true? Now, why do you think that is not, or so that 40 times does not always get related to the attraction of the valence electron? Because why? Reason is there are, what do you think, guys? 79 electrons in between the nucleus and what? The valence electron. Which means what? This is what? This other 79 electrons what? Causes shielding. Okay, so you gotta understand, guys, okay? So yeah, that's a valid point, right? Because what? There are 70 or 9 or so, what, guys? Non-valence electrons, which what? Exerts shielding, okay? Which means what? Not every of those like 80 electron proton is gonna get to the valence electron, okay? Which weakens the ZF, okay? Effective nuclear charge. That's why what? It's very easy to pull them out. An example is, for example, guys, in one hand, you got like single dollar bills with 80 single dollar bills, okay? On this hand, you got 2, okay? Where would you be easier to lose money from? Like $80 and $2? You got, where do you think you're gonna lose one and not even notice? Of course, the bigger stack, right? So that's what this is, guys. Just have understanding, guys. So yeah, feel free to ask questions, guys. It's fine, yeah? So keep that in mind, guys. I mean, the shielding comes into effect. I don't think you have to explain. Like, I don't think they will ask you, like, okay, so why this is like higher and lower, this is higher, guys. I mean, in that way, guys. But I don't think they're gonna go that far, guys, with the AP questions, by the way. But just have understanding, guys. Okay, lowest is here, highest is there, and the trend is that simple. But one thing to note. I mean, you'll see this question in the homework, by the way. The increase of the first energy ionization, right? It's not going up incrementally from left to right. That's something that they'll ask every time. Meaning, guys, let's take a look at it, guys, okay? So lithium, beryllium, okay, this is the S block, right? And you got P block here, which is boron, carbon, nitrogen, okay? And we got oxygen, fluorine, and neon, okay? So, dude, you guys should know, in terms of size of the atom, it gets smaller, okay, consecutively. It gets smaller, 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 okay? No question there. But now, you gotta ask yourself, guys, okay? Is the energy, this is important, guys, energy of ionization, does it go up every single time? Not true. There are 2 hiccups. Okay, so what I'm saying is this. I tell you, your teacher might not teach, guys, but this is definitely AP. You have to pay attention, guys, okay? So in terms of how it goes up, it might not be the reading, just so you know, okay? It goes up, okay, but there's a hiccup there. It goes up, hiccup, goes up. They ask this almost on every AP, okay? So the hiccup is, this is lithium here. This is beryllium. Boron is lower, okay? Boron has a lower energy of ionization compared to beryllium. It's easier to remove electron from boron than Be, okay? And also what, guys? This is nitrogen, that is oxygen, okay? Oxygen has a lower value than nitrogen, okay? They will ask this question, guys, and they'll ask the trend, and they'll ask you for you guys why. Typically, they ask you these guys a lot, okay? Nitrogen and oxygen. Why oxygen has a lower energy of ionization, even though oxygen is a smaller atom, okay? Even they have a greater number of protons, they have a greater nuclear charge, effective nuclear charge, guys. Why is it easier to remove electron from the oxygen is what they ask you a lot. So let's take a look, guys. I guarantee, guys, you can see the homework, guys, okay? So let's take a look. Well, the answer, first of all, the answer is, this guy's what, guys? The answer is always electron repulsion. Okay, that's the answer. So if you guys look at the orbitals, okay, so nitrogen guys, right? This is 2s, this is 2p, right? 2p orbitals here. So let's look at nitrogen here. So please pay attention, guys. This is nitrogen, guys. Okay, nitrogen looks like this. Okay, in terms of 100 joule, how you fill the electrons in, because why? It's 1s2, 2s2, 2p3 for nitrogen, okay? So that's the third one. This is 2p level, guys. 1, 2p1, 2p2, 2p3, okay? So if you look at this, so that's nitrogen, okay? So you try to remove electron from this guy. That's the last electron that's filled in. That's the one that's going out. If you're trying to remove electron. But now look at oxygen. So look at this, right? There are 3 orbitals. Each orbital has electrons in there, nicely like balanced per se, right? But now oxygen is what? Okay. There's one more. There's one more added in. Do you understand, guys? Yeah. So the energy of ionization for the oxygen is what? You're removing this guy. Okay? Like, yeah, think about it, guys. Okay, so imagine, just like what I said, right? 3 of you guys. Okay, you got you and 2 siblings of you guys, right? Like, oh, you guys had your own room and nice, right? Nice and harmonious, and there's no like, a lot of fight going on. Now, there's one more. Okay, you guys have one more kid now. I mean, not you guys, but one more sibling now. Now, what are you gonna do, guys? You're gonna start to argue where this person will be in. Okay? They don't like each other, by the way. Okay? So, oh, you should be in this room. You should be in that room. Like, they're gonna start to fight. Okay? That's exactly what's gonna happen. Do you understand what I'm saying? So, which means what? If you put these guys together, what happens, guys? They are in the same orbital. They're gonna repel. They don't like each other. Which makes it what? Much more unstable. So which means what, guys? So what are you gonna do? Like, so then what are you gonna do, guys? You ask your dad, put this guy in the basement or something. Okay, like, dude, take him out. Okay, take him out. Like, oh, get it out. So that's the reason why what, guys? Okay, so oxygen. Yeah, dude, like if this guy goes out, they're happy. Oh my God, they can't be better than this. So that's what's happening, guys. That's the reason why it's easier there's a less resistance to remove this electron compared to what? Nitrogen. Okay, so if you try to remove that guy, oh yeah, like if you remove, oh why you're going, it was so nice, but they're not want to remove that. But oxygen, yes, because why? Every time you have this what, guys? Electron repulsion for the oxygen, the last electron filled in. They don't like this one. Okay, so they ask this question every time. Okay, it could be a lot of times based on these two. Okay, like there's a hiccup. So keep in, I tell you, they test you on this one, guys. Size of the atom always goes down from left to right. Okay, but the energy of ionization is what? There's a hiccup, and that is something that yes, for the AP, you didn't record this to know, guys, for the SAT too. But AP, absolutely yes, no question there. Okay, if you're taking Olympiad Chem guy, I don't know when that will be, guys. They ask this question as well. College, no question. Okay. Any questions on there, guys? But again, the number wise, like, oh yeah, exactly what would be the number? What's the value? Like for example, this one will be like 834 kilojoules per mole. You don't have to know the numbers. You just have to know the trend, periodic trend for this. Okay. Any questions on there, guys? Questions, concerns, on there, guys? And there's a hiccup here, guys. Obviously, So, meaning, guys. So there's if these are nicely paired up, guys. But like, if there's one more here, which is like, like there are three rooms, but there's only one guy, this is relatively easy to take out, okay? So that's the reason why I think beryllium is lower. Boron is lower than beryllium, okay? So there's 2 hiccups you have to know, guys, on those 2, okay? And in the scope of AP, guys, a lot. So that is this is what we consider as first energy of ionization, okay? So now, what you guys have to know, guys, unless you have any questions, they will also have questions on. This has been a question for SAT 2. Probably school teacher definitely brought it up, guys. If you have a normal chem class, like before AP, is the understanding of, guys, second, energy of ionization, third, like fourth, and fifth. Okay, they will kind of want you to know, guys, the first, second, third, the fourth, and fifth, and it kind of goes down. You guys understand what they are and the trend of those guys, okay? So first and first, guys, okay? The first is what, guys? The first electron you try to remove. So if you look at it, guys, for the first one, sorry. The first one is, okay, so this is the element X, okay? energy needed, E1, okay, that's first energy of ionization, right? Turning into X plus gas plus electron. You see that, guys? That is what? The first energy of ionization, first electron you're trying to get removed from the atom, okay, the gaseous state. But now, yeah, listen carefully now. This is like ionic radius. So the second is what, guys? Second is, okay, this is when they lost one electron, right? So second is what? X plus gas, which is like from this guy, right? You're trying to remove a second electron. So, okay, so which means what? That's E2. So not only one, but you try to get rid of a second electrons overall, okay? So X2 plus gas plus electron. Do you understand, guys? So let's compare E1 and E2. E1 and E2, okay? So what you guys have to understand is this. Regardless of which element it is, E2 must be greater than E1, no question there. Doesn't matter which element you're talking about, guys, here, E2 is always greater than E1, okay? There's no question, absolutely no question there, okay? So you have to understand, okay, so why? Why does it go up? The reason is what, guys? So you gotta understand, if an atom, okay, they lost an electron. The electron popped out, okay? Became what? It became a positive charge ion, right? Yeah, dude, it became a positive ion, right? What happened to the size of the atom? When atom loses electron, what happens? What happens, guys? If they lose electron, okay, electron pops out, it becomes positive charge ions. What happens, guys? The size of the atom, or ion now, gets what? It gets smaller. So keep in mind, guys, here, when an atom loses electron, their size always gets smaller. And you have to ask yourself, okay, so why? Why do they get smaller? So imagine, guys, okay, if electron pops out, okay, so electron, what do they do, guys? Electrons repel each other. Each electron is what? They repel, they push out, okay? If you remove one, what happens, guys? The existing remaining electrons, residual electrons are what, guys? They're what? The repulsion decreases, which means what? They're gonna get closer to nucleus. So which means what, guys? If they lose electron, what happens, guys? The size of the ion is what? Smaller. You understand, guys? Size of the ion gets smaller when the atom loses electron. Keep that in mind, okay? Yeah. Someone went in, so you might want to go, like, when the guy comes out. When you hear the noise of the room, then you can come out.
There's another one.
It's too far. It's wait for this to happen. So guys, keep in mind, guys, so when the size gets smaller, what happens, guys? Yeah, dude, like electrons are close to nucleus, what happens? They're harder to remove. So every electron they lose, so which means if you have a positive charge ion, it means what? They're relatively what? Next one is harder to remove, okay? It doesn't matter which one it is. And same thing goes for third one, guys. So yeah, they lost two, and what? They're trying to lose one more. So this is E3, right? You get to understand it, right? So it becomes X, 3 plus gas and what, electron. If you lose a third electron, what happens, guys? Yeah, dude, this is what? This is also greater. So you gotta understand, guys. Every successive ionization, guys, what happens, guys? Their value increases. So why I'm saying this, guys? On the AP, okay, they will have a question, okay, based on this number, the trend of the ionization. Something like this. So first thing first, guys, dude, like it could be anything, right? They can ask you guys, okay, so why do you, if you lose electron, okay, like, okay, so why does this get a bigger number? Let's ask you a question, because why? What happens, guys? Less electron repulsion between the electron, the size is smaller. That's one reason why. And then the question that I'm referring to, guys, this is definitely something that we talked about during the SAT class and stuff like that. So, meaning, guys, they give you guys the like a spreadsheet. Not a spreadsheet, but just a list of E1, E2, E3, E4. I mean, you've probably seen this question, guys, like reading as well. I provided, guys. They give you this, okay? This is the first energy of ionization, guys. Second, third, fourth, fifth, and sixth, and seventh. Like, it kind of goes like that, okay? And then E1, the number-wise, for example, I'm just making this up. 80 kilojoules per mole. Okay, this is 150 kilojoules per mole. This is 300 kilojoules per mole. Okay, and now it becomes like 3,000 the fourth one. 4,000, this becomes like 6,000. You see that, guys? They give you this, so 80, 50, 300, 3,000, 4,000, 6,000, okay? They give you this, and they ask you, okay? They give you like elements, right? So A, B, C, D, E, okay? And they ask you guys, okay, so where is this element? Which element can this possibly be with this pattern? So they give you guys, okay, so this can be lithium, can it be boron, can it be beryllium, okay, can it be carbon? They ask you this question, so which one is it? You know, which can have this kind of pattern is what they're asking. Okay, I think, so, what do you think, guys? So you gotta understand, guys, okay? So it follows normal trend as well. It increases. There's no question there. Right? It goes up, okay, it goes up, right? It should never go down. But what do you have to look at? You gotta look at what, guys? How much it goes up successively, like, you know, it's a succession perspective, right? So you look at it, guys, what happens, guys? It goes up, but there's what? There's a big jump here. You see that guy, 300 to 3,000, 10 times. What does it mean, guys? Yeah, so, okay, so they lost, so up to here, they lost what? 3 electrons, right? And then, okay, so what about here, guys? What happens, guys? The 4th electron, they resist a lot. Yeah, what does it mean, guys? Well, whatever this thing is what? It's got what? 3 valence electron, okay? And the 4th one is what, guys? Non-valence, okay? It's like inner shell, it's hard to remove. So which means what, guys? You gotta find the choice for what, guys? It's what? It's got 3 valence electron, which is what? Boron. Okay, so that is one of the AP questions, okay? It's not hard. If you know what you're doing, guys, it's not bad at all, guys, because this is AP. Okay? AP question will have this question, oh yeah, by the way, based on the pattern, which one is it? You have to look for what? Abnormal jump. That will tell you what? How many valence they got. You don't understand, man. I tell you, like the past the AP Chem class, man, I mean, you don't understand. I keep teaching, and they still get it wrong. Like, I don't understand, but you know, like this is the easiest thing, like very like, you know, like low-hanging fruits, guys, okay? So shouldn't be getting these wrong, by the way, okay? Any questions, let me know. Questions, concerns, issues, guys, let me know. Okay. So you definitely, guys, some definitions, you have to understand what the energy motion is, and you know, possible, like, you know, hiccups, you know, and also the trend per se, you know, in terms of a first, second, third, and fourth, and blah, blah, blah. And then they're asking which one element it is and stuff like that, guys. This is your homework, so if you don't get it wrong, guys, please, yeah? All right, so isn't there a question, guys, in the reading as well, guys, or something like that? So definitely you've seen them, okay? All right, let's move on to, guys, a couple things, guys, okay? Let's talk about electron affinity. This one, guys, not so much asked on the AP, okay? This one, they can, absolutely no question they can ask this question, okay? But not to much of an extent. You have to know what it is, no question there, okay? But they probably will not ask you for a pattern or like, you know, like an equation or so, guys. They will never have that. But absolutely no question, guys. You have to know what it is and what it represents and all that stuff, yeah? So electron affinity is what, guys? So it's sort of the opposite, not really opposite, not complete opposite, but it's a different, like complete, like a little bit opposite pattern of the energy motion, guys. So it represents amount of energy releasing, okay, when an atom gains electron, okay? So for example, guys, if element X gains electron, so it's kind of the other way around, right? And what turns into what? Negative charge ion. Then what happens, guys? Yeah, dude, it releases energy. Okay? So electron affinity is what, guys? How much energy releases, okay, when an atom in a gaseous state gains electron? So, dude, like think about it, guys, right? Did we talk about this electron transition? Okay? Think about it, guys. This is an electron here, okay, the N2. Let's say, for example, this is a valence electron, right? We talked about this, right, last week. If you're trying to remove electron, right? What happens, guys? If the electron moves away from a nucleus, what happens, guys? Energy must be put in. We talked about it, right? If, like now it's what, guys? Like this is what? This is the energy of ionization, right? This is what? This is going reverse. It's going down. It's going down. You understand, guys? Which means what? Like, dude, if electron comes to the element, what happens, guys? It's what? Like, dude, this is what? It should give off energy. Because what? Electron from the higher level to lower level. So amount of energy actually given off by gaining electron is what we call electron affinity. Okay? So the pattern for this, man, I tell you, like, it's all over the place. Okay? So the reason why they don't talk about it. So, okay, so think about it, guys. Okay, based on a typical pattern that we know, okay, which one should give off most energy then? Okay? Like, okay, so people might think fluorine. A lot of students will think fluorine. Okay? Fluorine, because it's the most, like, you know, like corrosive, like gas. If it gains electron, it turns into what, guys? Like F minus. It gives off a lot of energy. Okay? Then people think that. Because what? This is all over the place, right? What do you think? No, is it fluorine? No, it's not the answer. Chlorine is the answer. Chlorine has the highest value, by the way. Okay? Chlorine and then Br, and then fluorine and then iodine. Okay? So it's a, you know, and then also, guys, keep in mind, guys. Okay? If energy gets released, because you guys have understanding on this one, what happens, guys? This the value is what? Negative. Okay? Like delta H being negative value, for example, guys, is what? Energy given off, right? But sometimes, I guess, you know, like noble gases, okay? Noble gases, what happens, guys? So, dude, they will never try to gain electrons, okay? Noble gases never gain electron, which means, guys, you'll never see stuff like this. Like neon, think about it, guys, neon gaining electron turns into what? Neon minus. This never happens, okay? Once you have the octet, they never gain more electrons. This is not gonna happen. But you try to force electron to be in there. What do you think will happen, guys? I mean, do you think they're gonna release energy, guys? No, energy must be what? Put in, because why? This is not a very favorable process, okay? So this guy is, I mean, I don't know, your teacher will talk about it, I'm not sure. You know, but again, this is something that the AP doesn't like to talk about too much, okay? They will ask you for the process, what it is and all that stuff, but on the question perspective, they don't have it a lot. But your teacher, I don't know what school you guys will go to, I'm not sure, guys. You guys told me, I forgot, but you know, you know, as we know, guys, as you know, your school teacher perspective, I don't know. They might have some questions on this one, like, who knows, man? I mean, Olympiad chemistry, they have questions like this as well. Like, oh yeah, by the way, which of the following has the highest value? You gotta know what it is. The trend line, you gotta memorize some of them. But for us, AP level guys, I mean, strictly from the AP perspective talking here, you do not have to know the whole purpose of the trend. And also, guys, you have to know just what the definition is for now, because this is something that we have to discuss in a bonding chapter as well. So this actually comes into a factor for the bonding a little bit. But that's where we need it. You have to know the definition. That's all there is for this part. Okay. Any questions? Let me know this one. Any questions, concerns? Let me know, guys. All right. So as we discussed, okay, one thing that I need to discuss with you guys is right now. Okay, this is AP only. Okay, you will not see this question anywhere else. You'll probably not see this question on the MCAT or, I don't know, man, like anywhere else. One thing to note, guys, it's about binding energy. Okay, they have this, I tell you, every single year, every year, okay, starting from 2014. Okay, now, every year, I tell you, it's very easy, okay, if you are taught, okay, but sometimes like they don't teach this, so they don't know. It's called binding energy, okay, binding energy, okay. So like, okay, so what it means by binding energy in AP Chem perspective is what? Amount of energy needed to remove electron at a particular shell in the sublevel. Okay? So for example, guys, okay, so like carbon, right? Carbon is what, guys? 1s2, 2s2, and what? 2p2, right? That's the electron configuration, right? So amount of energy needed to remove what? Electron from the 1s, 2s, and 2p. Okay? That's what we call binding energy. I'm gonna put it very simple here, okay? So, and you gotta know like some kind of, like, you know, crap on this one. Okay. So I'm telling you guys, they have these things, guys, by the way. Okay. And now this, on the y-axis, you'll see a question, guys. I'll give you a question today, guys. This is relative number of electrons. Relative number of electrons. Instead of elements, number of electrons, okay? And this is what, guys? This represents, guys, the energy, the binding energy, guys. But one thing to note here, guys, this is the higher, this is lower. Okay, like you know the x-axis, by the way. Typically, what, like you go from low to high, but not true, guys. This is the higher one, that's a lower one. Okay. So basically, you'll see a couple of peaks in the graph. Okay. So you see one here, you see here, and you see this. Okay, that's what you see. Okay. So, okay, so this represents what? This energy here, guys. This is on the bottom is energy. This is binding energy. So if you look at it, guys, okay? So, okay, again, what's the energy, guys? Here's what amount of energy needed to remove each of these what sublevels and principal energy levels, right? Yeah, think about it, guys. Which electron is hard to remove? Is it from the 1s, 2s, or 2p? What do you think, guys? Of course from the 1s, right? 1s is what? It's closer to the nucleus, which is what? This right here, whichever one requires a higher energy is what? This is what? This is a 1s peak. Okay? It's very, like, dude, it's a very simple thing if you know what it is. This is what, guys? This becomes what? The next one, which is 2s. This is what? 3s. I'm sorry, 3p, 2p, I'm sorry, 2p. And their peak is the same. Because why? Yeah, why? Because why? They have the same number of electrons each sublevels, right? This is what we call binding energy. Dude, I'm not kidding, man. This is what it is. And they ask you to draw the peaks on the graph, guys, and it's not like that fancy, okay? And now, okay, so what about if you have a neon? Neon is what, guys? 1s2, 2s2, and 2p what? 6, right? So there's 3 times the number of electrons in this guy, right? So first thing first, they'll ask you, okay, so what is the difference between neon versus, like, this is for what, guys? This is for carbon, okay? For neon, what are the difference? So keep in mind, guys, okay? If neon is what, guys? Neon has a greater number of protons, there's more protons, right? There's more protons. What do you think will happen? More proton is what, guys? These electrons are pulled in stronger, which means what? Like, okay, so for what? Neon, what? The peak will be a little bit more towards what? To the left side, because what requires a higher energy. This is 1s for neon, because what? It has more protons. It's harder to remove electron from the 1s. Okay, and 2s is also a little bit higher in terms of energy-wise, and also what, guys? 2p is what, guys? Now, much higher peak, because what? This have what? 6 electrons versus 2. So that's what they ask you. It's nothing fancy, okay? It's very easy in terms of binding energy, okay? But that's something they asked you on AP Chem since 2014 to now, every single of them, okay? In terms of binding energy. So I mean, again, you'll have to see a question to really kind of see what it is, and it's really, guys. If you know it, this is easy. If you don't, then it becomes actually a for our question, by the way, okay? So let me actually, guys. Pretty nice. Give me a second, guys. Let me show you guys what I mean by this. Did you guys bring your devices, by the way? Do you guys have you guys all wear a computer? You guys have it? Let me send you guys a question right now. Right, so take a look at it, because I want to print it out right now. All right, so take a look at this, and give me a second, guys.
Wait, through email?
Yeah, I'll send you through email. Oh, give me a second. Sorry. You guys like it, right? Who doesn't have a device? Take it out, please. And
Can you use my phone?
do you have a laptop?
No.
Yeah, you can. Please, guys, bring your device, guys, again, so that minimize the time for me to. Yeah, cool. I'll get them all. Alright guys, I'm gonna put the question, guys. You guys all have the Wi-Fi, and I don't know. I'm sure you guys. It's the first question I'm giving you guys, okay? So please take a look at it, and we'll look at it together. So I just send it. Okay, check it, guys, please. And the first question, first FRQ, guys. That's what I'm looking at.
Is it possible to lower the AC? It's really cold.
Sit somewhere else. Like sit there.
Really?
Yeah. Guys, bring a jacket or something, guys, if you're cold. You guys got it? Didn't get it? You got it? First question, guys, you got it? Let me know if you didn't. So write your answers, guys, on the paper, guys. I'll give you like 5 minutes. So A is what we just talked about, okay? And part B is like calculation stuff that we talked about last week, okay? So the wavelength and stuff like that. So the equation that we talked about, guys, is energy is equal to, guys, HF. And the speed of wave is equal to lambda times frequency. That's one of the stuff that we talked about last week that I told you. You have to know them. So in case you guys, you can use a calculator if you want to, guys. Speed of light is 3 times 10 to the power of 8 meters per second. And the Planck's constant is 6.63 times 10 to the power of -34. Okay, so that's the constant values, guys, and that's a frequency. That's a wavelength. Okay, so so you can know what we talked about it, guys. You gotta be able to know the equations, guys. It's all the equation based on the equation provided. Okay, and this is you can see it 2019 ATPM, right? I'll leave this here for you guys to look at if you peek at it. Probably need your periodic table, guys, by the way. I mean, if you guys don't know, if you didn't memorize the periodic table, guys. If you do a lot of questions, man, I mean, I don't think, like, for these, I don't know. please have all the, I mean, I have the answers, guys, okay? So have the answers ready for this question. 2019, what year, what number was this? Number 9 or something? Or number 5? Just take a look at the first question, email. I'll go over this, guys, in about like 1 minute, okay? So get your answers ready, guys. Okay, guys, let's take a look at guys. So the first part of the question, guys, you guys have the diagram, guys, a complete photoelectron spectrum. Okay, they call this photoelectron spectrum, which represents the binding energy. Okay. So they're saying, guys, element in the ground state is represented below. So now they have like the peaks look like this. Okay. So based on our discussion, okay, this is 1s, 2s, 2p, okay, 3s, 3p, 4s. Do you see that, guys? Okay. And from what you can tell, this is relative number of electrons on this side, okay? So which is what? It represents 2, this represents 6 electrons, okay? So understand this, what happens, guys? So it's what? This will be 1s2, 2s2, 2p6, 3s2, 3p6, and what? 4s2. And that's what it is, right? So, you know, in terms of a configuration. So I don't have a periodic table, guys, but I thought this was what? Calcium. Calcium is the answer, okay? So if you look at the periodic table, guys, like, when you see it, sorry, you left it here. This guy is like right there, calcium right there. Potassium, calcium number 20, yeah? Any questions there, guys? Let me know. So the first part A1, ground state configuration right there. That's the ground state electron configuration. So now, yeah, listen carefully, okay? When they say, yeah, I think I mentioned this before, right? If they say, give me full configuration, you gotta write 1s2, 2s2, 2p6, blah, blah, blah. You got to write the whole thing. But now if they say, just write the configuration, it becomes what? It becomes what? You gotta just write AR and what? 4s2. That's good enough. So, you know, okay? So either one, I mean, if you guys put one of these guys, that's correct, okay? Any questions, let me know. If you don't know, guys, like raise your hand and please let me know, guys. Questions, let me know. I guarantee you guys, when you guys take a test next year, guys, 2022, you have these are on the test. I guarantee you guys, either multiple choice or FRQs or both. Any questions on this one? Let me know. So this is part A, which is like, I don't know. I mean, again, if you got it wrong, it's fine, okay? As long as you know it now, that's fine, okay? In the next part, okay, which is what the question is asking, okay, listen carefully. Calculate the wavelength in meters. Wavelength is what? This guy's wavelength. Okay. Of the electromagnetic radiation, we talked about it yesterday, okay? Electromagnetic radiation needed to remove the electron from the valence shell. So like, okay, yeah, which one is valence shell? 4s, right there. That's the valence shell. Do you understand, guys? Okay. So okay, from the atom or the element. So what are they asking, guys? Amount of energy needed to remove electron from this guy. They gave the energy, which is what? Which is 0.980 times 10 to the power negative 18. They give to you, okay? So amount of energy needed. So keep in mind, guys, okay, binding energy is not really, like energy of ionization, but it's the outermost. It's fine. So that's the only way you can utilize. Like that's the only value that you can use. Okay. So which I think is what? So energy is equal to what, guys? HF. Okay. So we can get the frequency. But now energy is what, guys? Based on what's provided, guys. Based on what I think, it's what the amount of energy is what? Okay. So I have 0.980 times 10 to the power of negative 18. That's the amount of energy needed to remove the electron from the 4s, okay? Is equal to H, which is what, guys? H is, as I mentioned, 6.63 times what? 10 to the power of negative 34. Times what? Frequency. That's a question, guys. Like, that will get you the frequency, because they're not asking for frequency, they're asking for what? They're asking for the wavelength. So, but now if you, okay, so frequency, okay, so if this is the equation, guys, for this, I need this guy. Okay, so the equation is, okay, C, which is, equation is C is equal to lambda times the frequency, okay? So C is equal to, if you look at, this is what I need, right? So frequency is equal to what, guys? Divided by this by that, or whichever way you'll do it, guys, C over lambda, okay? So you can put this guy in place of the frequency, right? Because they're the same thing. So if you look at it, guys, then I'm gonna put, guys, the speed of light, which is 3 times 10 to the power of 8. That's C divided by lambda. That's the equation. Okay, if we solve this, you get the wavelength. You understand, guys, here? Any questions? Like, if you don't understand, guys, like, oh, fine, I get it, man. I gotta explain it again. Let me know. Any questions, concerns, let me know. Because I thought, I mean, I didn't give you a question on this one last time, but like, just to kind of give you the answer first, guys, when you solve it, this is what I got. I mean, my answer hopefully is right. Lambda is equal to 2.02 or 3 times 10 to the power of negative 7 meters. Okay, sometimes, guys, a lot of times, guys, they want you to write. I mean, so this is fine. That's, if you put it like this, guys, that's a good answer. Sometimes they want you to put in nanometers, which means if this is what, guys, 203 nanometers. Okay, right there, that's the answer. So if you have the wave like this is more in what, guys? Like blue, like violet range, so violet or going into UVs, in terms of wavelength perspective. There's the answer, if you get it. So yeah, I didn't make this up, guys. This is AP Chem. Okay, this is AP Chem, 2019. Very relevant question, by the way. Okay, if you don't understand, like, dude, like, I don't know, what are you doing? Let me know. Any questions, concerns on this one? If you don't know, let me know. Concerns, let me know, please. Because it only gets harder. This is like, I put it first because it's the easiest one, by the way. Questions, let me know, guys. So let me tell you guys, okay? So you don't just have a hard time with the equation, okay? I get that, okay? But you gotta get yourself familiar with the equation, okay? And then it's very easy algebra, so it's nothing fancy, okay? But let me know any questions. I'm not trying to make you feel bad if you got it wrong, yeah? But so any questions, concerns, issues, let me know on this one. No, all good. So let's take a look at the second one. Second one, guys, number 5. I forgot what number this is actually. This is a harder question. Second question, guys. We got they gave you the ionization energy, okay? So let me first thing first, guys. I mean, this is recorded, by the way, so you can always go back to the recording, guys. So the second question, before I get there, okay, let's talk about one portion of this chapter, which is what we consider as the reactivity, okay? So when you look at a periodic table, okay, this is a periodic table, guys. So, and I mean, again, you guys should know it. There's a line there, okay? So you got a periodic table. I mean, something like periodic table I give you guys don't have a line, but the like regions level, lower level guys, they have a line there. So you guys should know everything on this side is known to be what we call the metals. This is what we call non-metals, okay? And this, whatever that's on this line, I mean, some of them, not all of them, is known to be what, guys? Metalloids, okay? They can be metal or non-metal, whatever, okay? Like they show both, like, semiconductor capabilities and stuff like that, guys. Not so interested in those. We had to talk about them, but not now. So metals. Okay. So metals react. You guys know that, right? Metals react. There's no question there. Okay. So yeah, keep in mind when metals react, what happens to them, guys? When metals react, what happens to them? So you gotta understand, guys. What the hell is reaction? Reaction is what, guys? Reaction is when an element or atom loses electron or gains electron. Okay, that's a reaction. When something loses electron, gains like there's a reaction. What else, guys? Bond breaking and forming. That's what reaction is. Yeah. When metals react, what happens, guys? Metals, they lose electron. Okay? Metals will always lose electron. So whenever you have a metal, for example, these questions talk about what? Sodium and potassium. Okay, what happens then, guys? They lose electrons, okay? Which means what? These guys, Na, comes what, guys? Na plus electron. Okay? So let's talk about that, okay? If a question on your test asks you reactivity, which means what? Okay, which of the following is more reactive? What do you have to look at? Like, so, oh yeah, which of the following is more reactive? Higher reactivity as a metal. Okay, okay, so which one is more reactive, right? What do you have to look at? Metals react, and what do they do, guys? They lose electron, okay? And when they lose electron, what do you have to look at? So more, like if they lose electron more easily, okay, it doesn't take a lot of effort for them to lose electron. What happens, guys? They are more reactive, okay? So, which means what, guys? So in terms of metal perspective, what happens, guys? Yeah, this is what? If energy of ionization is a lower value for the metals, what happens, guys? They are more reactive. As you know, guys, so trend perspective, right? If you go down, it's easier to remove electron, right? So compared to FR, like these are what? More like less reactive, right? Because what? These guys, this one has a smaller energy of ionization, what? But these guys have a higher value. So which means what? My understanding is, I mean, I didn't even look at the values, but I anticipate that what? Sodium is less reactive than potassium, because what? Sodium should have, based on the trend of what, guys? Should have higher energy of ionization compared to the. You have 5 minutes, okay? So like 4 minutes, so you can go after. Unless you really have to go. So this one has what, guys? Like, yeah, dude, this one should have what, guys? Have a greater energy of ionization, which is what? Less reactive. Because that's the understanding, right? So, you know, so if you guys go to that little table there, okay, element and then the first energy of ionization, the sodium has a higher value. Okay, there's no question there. 4.95 versus 4.19. Sodium has it's harder to remove electron from sodium. Okay, there's no question there. So now the question is asking, right? So the first question, write the electron configuration for K+. Okay, so let's take a look at that, guys, okay? K+, guys, it's next to potassium. So let's take a look. So, yeah, so keep in mind, guys, K+ means what, guys? They already lost electron. Okay, so yeah, let's write K first. Okay, let's write K first. Okay, that's why it becomes 1s2, 2s2, 2p6, 3s2, 3p6, and what? 4s1. That's what it is, right? You can write it also like this, right? You can also write it like this. Okay, AR and what? 4s1. So that's K, right? So if they ask you for K+, what do you think, guys? Yeah, you can get rid of this guy. Okay. Or can you do this? Yeah, can you put it like this? If you put it like this, you get it wrong. I'm not kidding, guys. If you put it AR, you get it wrong. Absolutely no question, guys. This is wrong. You cannot put it like this. You gotta put it what? You gotta put it neon and what? 3s2, 3p6. You gotta put it like this. Okay, this is the right abbreviation. Okay, so this and this, either one or the other is for the K+. Okay. That's the first question, like super easy, right? Like, dude, like, okay, it's not that bad, right? So in part B, guys, the question is asking, based on the principles of atomic structure, explain why the first ionization of potassium is lower, so it's easier to remove, because why? It's got what? The potassium is what? At a higher shell, the electron in the valence shell is what? Higher than sodium, okay? Which is what? It has a weaker, what? Attraction to a nucleus, okay? Because what? Yeah, it's easier to get them out because what? It has a weaker what? Coulombic attraction to nucleus. That's something you can mention. You know, you always want to mention, guys, a question like this, a Coulombic attraction in a response, okay? So, and yeah, we'll have to, guys, I mean, C is where the real question is and where we have to discuss. I don't have time for this, guys, but now, your homework, guys, I guess. So I have your emails, guys. And I'll assign a homework, guys. It will be I forgot how many questions, guys, by the way. It'll be, let me see, guys. Okay, so I'll assign, give me a second, guys. I already assigned, I think, but I have to assign you guys on this group, I think. Give me a second, guys. So the homework, guys, will be 21 multiple choice questions there, okay? It's not a lot, okay? 21 multiple choice. I mean, I'll give you guys an email, send you guys an email, if not today, tomorrow, Monday, with the instruction, guys. You have like 5 days to do it. It's only 2 questions, guys. It's relatively simple, multiple choice. It's not too bad, guys. And once you're done with that, guys, we'll take a look at the FRQs, okay? All right, guys. I'll let you guys go. I'll talk to you guys next week. Okay, guys. And guys, like before you guys come here, guys, like use the bathroom, guys, okay?